Global climate change. Okay, so local weather is strongly influenced by global climate factors. Changes to the global climate can result in changes to local weather, increasing the chances of extreme weather events such as droughts and floods. Once you have viewed the investigative phenomenon video and used the claim evidence reasoning worksheet to craft an explanation, answer the following questions about things that might cause an increase in floods. So where does the water that causes a flood come from? Why is the flooded area not inundated by water all the time? So again, we're going to think of the water cycle. So the water cycle is a continuous process of evaporation, condensation, and precipitation. When the ocean water warms, there is more water vapor in the atmosphere, which creates floods. Evaporation occurs when the sun heats the rivers and oceans. Water becomes water vapor and it rises in the air. Condensation takes place when water droplets, gases, and dust particles form clouds. Precipitation happens when the cloud becomes too heavy and it can't hold any more water inside. It bursts open to pour out rain, hail, or snow. When it rains, water is collected in oceans, lakes, and rivers. It seeps through the soil and becomes groundwater. Most floodwater forms rivers and streams that flow into the oceans. And so for the next one, question 2, it states, what type of information would you look for in meteorological records to identify patterns in the locations, frequency, or intensity of flooding around the world? How long a period of time would you need records for in order to identify global patterns in flooding? So, meteorological records include weather patterns, seismic activity, and historical documents that provide early warning systems to anticipate future disasters. It includes weather factors such as temperature, humidity, wind speed, and precipitation, such as rain, snow, or hail. It includes severe weather such as storms and tornadoes. Slower rivers will cause flood warnings within 48 hours, and then smaller, faster rivers create flood warnings within 12 hours. The more available information, the better it will be to predict future global patterns in flooding. All right, so now we're going to discuss the greenhouse effect. So, climate change is one of the most interesting topics of geoscience because it combines the sun's fluctuations, planetary orbits, atmospheric chemistry, radiation physics, ocean circulation changes, and biomass and land feedbacks. It is also a highly relevant topic because of its impacts on human society, past, present, and future. Currently, the biggest changes to climate involve increasing greenhouse gas concentrations. So to understand climate change, we first need to understand the greenhouse effect. Okay, so this diagram here illustrates the Earth's energy budget. The greenhouse effect is part of Earth's surface energy budget, which begins with incoming radiation from the sun, mostly as visible light. Okay, so we have the sun, it's showing the sun right here. There's solar radiation absorbed by Earth's systems at 241 W over m squared. Energy absorbed by gases in the atmosphere. Okay. And then energy absorbed by land and ocean surface. So we have thermal radiation that's lost to space, heat and energy in the atmosphere, and then energy is also re-radiated back into the Earth system. Okay. And then we have the greenhouse effect. So there's greenhouse gas absorption, there's energy radiated from Earth's surface, energy re-radiated into Earth's atmosphere. And then thermal radiation is radiated to space from surface. And that's what this arrow right here is showing. All right, so what are greenhouse gases? All gases absorb electromagnetic radiation, but each gas absorbs radiation only of specific wavelengths. Greenhouse gases are particularly effective at absorbing wavelengths that correspond to infrared radiation, the kind of energy that Earth's surface emits. Most of Earth's atmosphere is nitrogen and oxygen, which absorb very little infrared radiation. Greenhouse gases exist only in small amounts, but they absorb enough heat to keep Earth's surface about 35 degrees Celsius warmer than it otherwise would be. The global warming potential is a measure of the heat trapping capacity of a greenhouse gas over a given period of time, compared to that of a similar amount of CO2. Except for the chlorofluorocarbons, which have been banned because they destroyed the protecting ozone layer, the amounts of all greenhouse gases are increasing due to human activities. So this table right here, titled Human Released Greenhouse Gases, um, demonstrates the effects of greenhouse gases. There are different gases that warm the atmosphere to different degrees, and they remain in the atmosphere for different amounts of time. So they have very different long-term warming effects. So these are the two that we want to pay attention to, the methane over 20 years and then over 100 years. The nitrous oxide over 20 years and then over 100 years. The GWP of N2O is higher than that of methane and changes less when calculated for 20 and 100 years. Why does the GWP of nitrous oxide change less, and why does methane have a large total greenhouse forcing contribution? So the global warming potential, GWP, measures the heat trapping capacity of a greenhouse gas. The global warming potential, GWP, of nitrous oxide changes less because it absorbs very little infrared radiation and the concentration is much lower compared to methane. The greenhouse forcing contribution measures greenhouse gases. Methane has a large total greenhouse forcing contribution because it has higher concentration in the atmosphere. All right, so now we're going to look at oscillations of a water molecule. How do individual atoms vibrate within the water structure? Water vibration modes. So molecules vibrate at frequencies that depend on their mass, their size, and the types of vibrations allowed by their structure. The different kinds of vibrations can all occur at the same time. The distance between atoms of the water molecule can stretch in and out like a spring. This can occur symmetrically with both hydrogen atoms going in and out together, or asymmetrically with one going in when the other goes out. So the water molecule can oscillate by bending. The water molecules can oscillate by bending the arms of the hydrogen atoms out and in, with the angle between them alternately increasing and then decreasing. The water molecule can rotate back and forth around an axis of rotation, a process called libration. This twisting can occur around the x, y, or z axis, and each mode has a different frequency of oscillation. Okay. So again, this one's the x-axis, the y-axis, and this is the z-axis. All right, so for radiation absorption and re-radiation, when gas molecules absorb electromagnetic radiation, the radiant energy transforms into kinetic energy of the molecule. Motions of the molecule become more energetic. Eventually, the molecule remits the energy as radiation, but until it does, the molecule moves with more kinetic energy. These motions can take three general forms: stretching, bending, and twisting. Because different molecules have different sizes and shapes, they stretch, bend, and twist at different frequencies. It is similar to the way that bells of different sizes and shapes make different sound pitches and tones. This is why different gases absorb and radiate radiation at different wavelengths. All right, so for question 4, it states that water vapor has more distinct ways to absorb radiation than oxygen gas does. Make a claim based on the diagrams as to why this might be. So what do you guys think? Huh? I can't hear you, honey. Yeah. Oh, okay. It's fine. Okay, so let me kind of give you a hint. So, water vapor has more distinct ways to absorb radiation because it is asymmetric. Oxygen gas is symmetric. So, water molecule is bent. It's shaped like this, right? Oxygen is in the middle, and then hydrogen is sticking out like this, right? So that's why water is asymmetrical. But oxygen gas, it's pretty flat, right? Um, so oxygen gas is symmetric. That's why oxygen gas is symmetric. Since water vapor and oxygen gas molecules have unlike sizes and shapes, they stretch, bend, and twist at different frequencies. For this reason, water vapor and oxygen gas absorb radiation at other wavelengths. Okay? Does that make sense to you guys? Yes? Okay, good. I'm happy to hear that. Does anybody have any questions?